This won't be too long. And the title of the talk is Docker for Devs. This is intended to be accessible. I'm not going to do any sort of crazy deep dives. And sarcastically, I decided to explain the difference between Scrum and Kubernetes. So, who is this guy? My name's Nick Gordon. I'm a developer for WeWork. I've been at WeWork for over 3 years now. I currently work on the identity platform at WeWork, which obviously probably means something different depending on what company you're at. But I work in Ruby as well as other languages. And I wish that I still spent most of my time in Ruby. In addition, I spend probably about half my time in meetings, 25% in Ruby, 25% in Go. So, things that this talk is not about. It's not about orchestration tools. It's not about Kubernetes or Swarm or any of those things. It's not about operating systems. I'm certainly not qualified to talk about those. It's not about service architecture. It's not about how to design your systems more better. This is purely about how to make our lives a little bit better as developers, how to make it easier to onboard people onto your team, and how to make it so that you have fewer differences between every single environment. So what is Docker? Since generally speaking, when we're talking about containers, we talk about Docker. Docker is the world's leading containerization platform from Docker. Cool. What is a container? This is just the definition from Wikipedia. Basically, the same idea. The idea is that we feel the commands that you execute are the same in the container, but it's actually interpreted differently by the host. So everything always acts the same as far as you're concerned, but it's actually just been virtualized to several degrees. And there's lots of fun implications and lots of fun security things you can do, but again, we're developers. That's secondary concerns, right? So why should we use Docker? Because it behaves the same, regardless of what I'm running it on. It doesn't matter whether it's on a Linux box. It doesn't matter whether it's hosted on Heroku. It doesn't matter where it is. You can even run it on a Windows box if you're a developer that runs Windows things. And on local, it actually decreases the complexity of requirements. I'm not sure how many of you have READMEs that are about 75% how to set it up for the first time, but I have seen a lot of those. Because you're probably using something that talks to a database, in which case, yeah, you're going to have a bad time. Anyway, so quick glossary. An image in Docker is basically an artifact that you can replicate. You can use it as many times as you want. A container is basically an instance of an image. A repository is a place that you store images. Dockerfile is a description of something. It's a way that you can specify a creation of an image. Volumes are basically folders that you can mount into containers when they're running. And Docker Compose is actually, sadly, a bunch of Python scripts that actually allow you to manipulate. You can describe it in YAML, and it allow you to manipulate your environment. The way the environment that your Docker container is launched in. So Dockerfile basics. Don't worry, we're mostly not on Ruby 2.5.1. We've upgraded. This is a screenshot from a while ago. So basic things from, I wonder what this means. This specifies what my initial starting point is. Run. I'm pretty sure we can all figure out what run does. It runs a command. Copy and add means that we're moving something from our host onto this new image that we're working on. And command is what actually runs when we execute the container. You can override this, but it's generally speaking. Best practices and goals. You want small images. Ideally, your images are not a gig. I have an image that on a service that I maintain that is a gig. It's not very fun. What does that mean? It takes longer to do. It takes longer to deploy. It takes longer to build, and it takes longer to download if you've got somebody new setting up on their machine. So, and the other thing to kind of think about is that you don't really want to put a lot of state in your images, because if the idea is that I can just spin it up whenever I want, if it takes a lot of state to spin up, then you're probably adding a lot of overhead there as well. Tricks to make your images small and fast. Layer caching, basically if nothing has changed, Docker will recognize that when you're building, so which means it just skips things. So if your gem file hasn't changed, then all of this will just be skipped, and you can just move on to copying your app folder over, which 99% of the time in every single one of our Ruby apps, I really hope in most of your Ruby apps, your gem files are staying relatively constant. Basically your build script will take about 2 seconds. The second thing is use Docker ignore, because that makes it even faster. Stateless images, essentially. Also, from personal experience, I would say don't use on-build images. They're technically deprecated, and they do way too much magic. And we're Rubyists. We already have enough magic in the language as it is that we get lots surprised by on a regular basis. So don't do it. Yeah. I don't know if you guys know about magic, more magic, but on-build is basically more magic. Docker Compose file basics. Version, you're probably going to be using version 3. Version 2 does something different. Networks are really cool. It allows you to basically build a namespace on your machine. And so everything within that namespace can talk to each other. And nothing outside that nothing that isn't in that namespace can talk to it. So you can think of this in the same way of I can protect myself. I can have my own little isolated database, and I don't have to worry about another server talking to it. But I can still actually declare that these 2 services can talk to each other. The other fun thing is volumes. I can declare volumes that are either local to my app, external to my app. They persist. And so for some of the tricks of getting Ruby running on a local environment, I actually persist my gems. And this allows me to basically get some of the same advantages that we get on our host machine of sharing gems and persisting gems across lots of things while still getting to run it in a container. Services, you can do fun YAML tags and so on and so forth. I'm just showing off a couple of very specific techniques in this. So first of all, in your image, you can override what you're running on. So if you're doing this in CI, so all of the Ruby apps that I work in, I actually run the exact same thing in CI that I run on my machine, which I don't know if you guys have ever had the problem of this always works on my machine. Now I'm going to try to get the test to pass, and they aren't passing, and I can't figure out why because it's something obnoxious about the server's configuration. Exact same thing, and that's powered by container tag. You can pull an environment file. I can specify specific volumes. So this right here, pwd-app, means print working directory. So I load the application code straight in. So I get all the same advantages of running on my host machine where I can just update. I'm writing my Rails app, right? I update a file. I get it immediately reflected in the container. Oftentimes we think of containers as requiring compiled. But no, actually, when you're running on your host machine, you can do it dynamically. Please don't do this in production, but locally it's fine. And you can actually even run, if you're Rails people, you can actually even run Spring, persisting in a container and play with that way. This basically caused me to bang my head into my computer for about 2 months until I figured this out. By enabling these 2 options, you can actually still use debug commands into containers. So enabling TTY and SDD and open, and a couple of little scripting things, you can actually attach into the container and still get the advantage of running bybug whenever you're running into the why is this thing doing this, what is this variable. I was so happy when I found that. So other fun things, you can expose default ports, you can alias things. So one of the cool things is that this particular system that I'm showing right here is our legacy ID system. And anyone who wants to talk to this within the network literally just is http://id. I wonder what service this environment variable is talking to. Becomes trivial to do. You can also set it up. So this is an example of overriding the Dockerfile command. So bundle exec sidekick, run sidekick as you'd expect. Yeah, you can also set it to do whatever ports you want, all of that. Next thing. I know I'm kind of talking through a lot of things. I'm open to questions afterwards. I figure just like rush through everything. And then if anyone wants to talk about Docker, because I can talk about this a lot. run is exactly what it sounds like again. It just runs a specific command and it runs a one-off container. So this, for example, is how you could run a Rails console on the command line using Docker Compose. Oh yeah, so this up does what it sounds like. It launches an instance of that. And so in order to spin up the Rails app, what I'll do is I'll launch Spring, I'll launch Redis, because I depend on Redis. I'm going to launch the web, and I'm going to do it in detach mode, and then I'm going to attach to it. When I attach to it, that's how I get the debugger in. And then when I'm done, when I want to cancel the thing, I just stop. This is basically just trivial bash scripting. You write it once, literally copy between all your services, and you're done. And that's actually fine to do in this case. One other little thing is that you can actually specify which file it is. So I have a separate Docker Compose.test environment, separate from my runtime environment. And you can share things between them or not, as you so choose. They're composable and various other things. But so I'm able to specify what file it's using. So I can have an isolated test Spring instance. I can have an isolated test. And then it becomes a lot easier to set up your CI as well. It also means that you won't accidentally drop your development database. Not that any of us have ever dropped a staging database by accident. So yeah, so this is just quick references. Basically, everything that I talked about here is excessively documented on like the Docker websites. It's great. Operating system. And most importantly, because this is a meetup, we're all hiring. These are the major cities that we are hiring more than 20 positions in. Yeah. And check us out at careers.wework.com. So thank you. If anyone wants to ask questions, you can either ask now or, I guess, in person later. If you think it's relevant for everyone, you can ask now. But yep. Is this more complicated? Does this just add? Allow me to rephrase your question so I can possibly ask it better. Does this add more steps to setting up users' configuration? Basically, is that? So I would argue that it simplifies users' configuration, because if you're going for the extreme case of this, basically all anyone needs, and this is actually what I have on my personal development laptop, the only thing that you actually need installed on that computer is your text editor and Docker. Everything else is maybe like an EMV file that you generate at runtime, or images that you're pulling down or building yourself. So it really depends on how extreme you want to go. Obviously, you're going to be doing certain things. You're going to add your debugger in. You're going to want to mix it. It becomes a little more polluted rather than that unbelievably clean case. But in general, I'd say it depends, which is a bad answer. But
because Puppet or Chef also are kind of configuration.
Puppet, yeah. Puppet and Chef do allow you to do a lot of configuration. That's why I said this talk is specifically not about orchestration tools, which is what Puppet and Chef are. This is specifically about how do I run my application code in a very specific, replicable way. Whereas getting into how do I configure and deploy my services is another layer on top of that. Docker Compose kind of fuzzy, makes that line a little fuzzy, but I can pretend that it falls solely under Docker because it's really just Python scripts attached around Docker run. Thank you everyone for having me.